5, 4, 3, 2, 1. Okay, a couple things. What's the definition of a function? Everybody together. A relation in which every element of the domain corresponds to exactly one element of the range. Good. Lots of you got it. About 10% of you do not. It's time to learn it. Let's talk about domain. Domain is just the x values. Yesterday we talked about 3 types of different functions in which we have different domain issues. Square root. Can't take the square root of? Negatives. So therefore you take 9 minus x and what? Greater or equal to 0. This is a review from yesterday, okay? So that we can try to solidify our learning. Subtract the 9, negative x, greater or equal to negative 9. Divide by negative 1, x is less than or equal to 9. So that means our domain is from negative infinity to positive 9. Square root functions, that's an absolute must. Got to be able to do that. Can you do that for the test? Second one, absolute must. It's a rational function. When you see rational functions, something has to go off inside your brain saying, I can't divide by 0. What number would divide by 0? 2. So x cannot be 2. That's it. For the next one, another rational function. Can't divide by 0. So I factor the bottom, x minus 3, x plus 2. What numbers can x not be? Be a negative 2. Shoot, I thought this was difficult. Cube root functions. Can you take the cube root of a positive number? Can you take the cube root of a negative number? Yes, you can. What's the cube root of negative 8? Because negative 2 times negative 2 is positive 4, and then times negative 2 again is negative 8. So cube roots do not have an issue with any negative numbers. So the domain of cube root is negative infinity to infinity, all real numbers. Can you take the square root of a negative number? No. So when you have a square root, you have to take the inside, 9 minus x squared, and set it greater than or equal to 0. That's an inequality that is of second degree. You learned how to solve that in your last unit. Fortunately, you know how to factor because you are super smart. And you factor it to 3 minus x and 3 plus x, greater than or equal to 0. We will go ahead and draw our graph. It crosses through negative 3 and positive 3. Is this parabola right side up or upside down? Due to the subtraction sign in front of the x squared, it is upside down. Am I looking for where it is above the x-axis or below the x-axis? So that would be from negative 3 to positive 3. You good? And we'll skip the last one. That was a little bit of review. Okay? Let's do a little bit more of a review. Okay? This is stuff from last year. We'll see if you remember it. It says, given the graph of the function f, this is the graph of f right here. Identify the following. It says f of negative 2. So I don't have a rule that I plug negative 2 and 4, so therefore I'm just going to look at the graph. And what that means is if I have a value x of negative 2, what is the y value or what is the height at that spot? 1. F of negative 1. It looks like there are actually possibly 2 spots. Do I choose the top one or the bottom one? How come? Because you have the dot filled in. So yes, f of negative 1 is positive 1. How about f of 0? It is positive 1. F of 1, I have 3 spots. Do I choose the top, middle, or bottom? Bottom, so it is negative 2. And f of 2 has a height of 1. So you should be able to look at the graph of a function and define those outputs. Is that review? Good. Okay. Let's do another review. Domain and range. I should be able to find the domain of this. Go ahead right now. Take about 40 seconds with a partner and try to find the domain and the range of this function set. Go ahead. Start. So when you started, did you do negative infinity or did you start at -4? Okay, so let's say negative infinity, and you tell me when the domain no longer exists. When I do not have a domain value, you tell me when to stop. Good. Negative infinity to infinity. Even though the graph breaks apart, there's still always an output for every x value. We good with that? Okay, for the range, we have negative infinity to, what did you go to for that? To 2, but 2 is in parentheses, is it not? Excellent work. And finally, the domain value that satisfies f of x is equal to 0. So f of x means the output. I'm going to put the line for an output of 0. Everybody agree that's an output of 0? What x value produces an output of 0? X equals -3 and 4. Good? Okay, say broad shoulders. So Mr. Gans, your shoulders are too broad. They're in the way. Yeah. Did a lot of weightlifting if you can't tell. That was supposed to be funny. I didn't get a laugh. Did not get a laugh. A little bitter. These graphs do not need to be perfect. Please draw them. Okay, as you take a look at my graphs there, we'll let you have just a moment to copy it down. How's the water? Nope. I drink my water as loud as I can. I choked on my water. It's on YouTube.
You okay?
Yeah, I'm gonna be all right. I'm gonna know CPR. All right, everybody got it? Okay, the second thing we want to be able to do is I determine graphically whether something is a function or not. In order for something to be a function, it must pass the vertical line test. So we're going to use the vertical line test to determine if they are functions. If it crosses more than once, then it's not a function. Is this one a function?
Yes.
Yes, it is. Some people say it's not because if you drag a horizontal line, it crosses 3 times. It is not the horizontal line test. It is the vertical line test. Is this one a function? How about this one? Yep, it is. You know, if it crossed over there twice, but you can see it never crossed over twice. How about this one? No, do the vertical line. Vertical line crosses that one an infinite number of times. So we have yes, we have no, we have yes, and we have no. We good on that? Look at how easy that was. 2 more things we have to do. We have to determine if these are functions just by looking at them, and then we need to graph piecewise functions. So it says determine whether the equation defines y as a function of x. And so what I want you to do is just take 10 seconds, guess whether or not these 3 are functions. Each one, yes or no. Quick, write something on top. Make your guess. Okay, here we go. How do we determine? We solve for y. And in this situation, as I solve for y, I subtract the 2x squared, and then I divide by -4. And I get y is equal to 1/2 x squared minus 2. Is everybody okay with that? All right, good. Mikey, give me an even number. Okay, so he plugs in 8 for x. He squares it to get 64, multiplies it by 1/2 to get 32, minus 2 is... So that means he plugs in 8 and he gets out 30. Notice how he just gets out one y value? Are you confident that no matter what you plug in for x, you're going to just get one y value? It's not all of a sudden going to spit out 3 or 4. We all agree? Okay, let's look at this one. Solve for y is subtract the x squared. So yes, this is a function. Subtract the x squared, we get y squared is equal to 9 minus x squared. Then what do we do to both sides? You square root. And when you square root a variable of y squared, you have to list both the positive and the negative. So watch what happens. If I plug in 0 for x, okay, so I plug in 0 and I'm looking for an output. I plug in 0 for x and I get 9 minus 0 is 9, and the square root is positive 3, and it says that you have a negative 3. So see how it produces 2 outputs due to the plus and minus? So therefore this is not a function. Who knows what that graph looks like? Yes, it is a circle. This is a circle right from your last test. This has a center of 0, 0, and a radius of 3, right? Yeah, so we know it's not a function, it's a circle. And the last one, I'm going to subtract the x and the 3 to get negative y cubed is equal to negative x minus 3. I will divide by negative 1 to get y cubed is x plus 3. And now we'll cube root. And as you cube root just provides one result. I get y is equal to the cube root of x plus 3. And so whatever you plug in, you're just going to get one output. So this is a function. This is a function. Everybody good with solving for y? What do you have to be, what is the thing that you think will lead us to think it's not a function? If you have a y squared, that's a good indication, right? So show that you get a positive and negative, and then you know it's probably not a function. Yeah, that'll be the same type of scenario. Y to an even power is going to be a problem for us, okay? All right, last one. Here we go, piecewise functions. This is new. It generally starts out confusing. We're going to make it as simple as possible. The deal is that f of x is made up of 2 different functions. The first one is y is equal to 3, and the second one is y is equal to x minus 4. Those are the 2 functions. Now, you can draw, I can erase pretty easily. You're going to draw this very light. Don't draw it dark, just draw it very light. But the first thing I want to do is get an idea of what do these graphs even look like. What does the graph of y equals 3 look like? What kind of a line? A horizontal line that goes through 3. Everybody agree that that's going to be the top one? And then the bottom one, x minus 4, what does that look like? Yeah, it's a slope of 1 that goes through negative 4. So it would be great if it was as simple as just drawing the 2 graphs, but that's not quite the deal. Right now, do those graphs pass the vertical line test? No, it crosses twice, doesn't it? So that means we got to get rid of part of them. And here's the key. We only draw y equals 3 for x values less than 2. So what we would actually do with this guy is we would get rid of that part. Yeah, we get rid of the part that's bigger than 2. And then for x minus 4, we only want x greater than 2, so we get rid of everything up until the x value of 2. You see that? Now that's not how I do it. Okay? I'll show you how I take people through it. Okay? Here's how I think is the best way. Well, how I just showed you is a great way to do it. Some people actually go through and erase, but here's how I like to do it. And here's the way most students, I think, like to do it as well. I like to figure out what happens when the graphs break apart. Everybody agree they break apart at an x value of 2? So I take 2 and I plug it into this function, and that will give me kind of that endpoint where it stops. What is always the output of this function? 3. Do you think there's going to be an open circle or closed circle? So at 2, 3, I put an open circle, and I draw that graph of 3 off to the left. I draw the left side of the graph. Then I'll do the next one. I plug in 2, and I get 2 minus 4 is -2. Do you think it'll be an open circle or closed circle? Closed circle at 2, -2. And I will then draw the graph of x minus 4 to the right. Again, remember, it has a slope of 1. So it heads off like that. And that's your piecewise function. So I like to come up with the endpoints and then draw one graph to the left and the other to the right. All right. So I won't just draw them all out and try to erase them this time. I'll show you how we'll do it kind of like how I teach everybody to do it. First, I just try to get a mental image of what the graphs look like. What does y equals x plus 3 look like? 3 is slope of 1, right? So you don't have to draw that because I'm going to erase it anyway. And then what does the graph of the x squared look like? Parabola centered at 0, 0, right? So those are the two graphs I want to keep in my brain. Everybody got those in their brain? All right. So let's plug in -1. When you plug in -1 here, what do you get? 2. So at -1, positive 2, am I going to have an open circle or a closed circle? Closed circle. And I draw then the graph of x plus 3, which is a slope of 1. That's a slope of 1. So people would say you're drawing down. Nope, this is up, going from left to right. This is going up. Okay? And then I do the x squared graph. I plug in -1, -1 squared, 1. So that's -1, positive 1. Open circle or closed circle? And I drop down and I come back up. Is that okay? Good job. Here's the last one. What's different about this last one? There's 3 of them. No big deal because we're super smart. We can hang with the best of them, right? Phoebe? Yeah. What does the graph of 4 minus x squared look like? Parabola that is upside down and it's shifted up 4 units. So it's going to look something like that, right? What does the graph of y equals -2 look like? Horizontal line through, -2. And what does the graph of x minus 5 look like? A line with the slope of 1 that goes through 5, or -5, and it heads off like that. Everybody got those graphs in their brain? All right, so I'm going to erase it, and we're going to actually find the endpoints to draw this graph. I plug in 1. What do you get when you plug in 1? 3. Open circle or closed circle? Open circle at 1, 3. Can somebody describe for me how I'm going to draw the graph the rest of the way? We're going to go off to the left, go up to, and then drop down. Yep, good. Now I'm going to plug in what? I'm going to plug in 1 and 3. So I'll plug in 1. What's always the output? -2. Open circle or closed circle? Open circle at 1, -2. I'm going to plug in 3. Output? -2, open circle or closed circle? Open circle. And what did that graph look like? Excellent. And then I'm going to plug in 3. As I plug in 3, the output is -2, open circle or closed circle? Open. Notice how it picks up right with this 3, -2. I'm going to draw a function with a slope of 1 headed off in this direction, and that's what I get. So that is your graph. That's a piecewise function. So take out your homework. Look, we're breezing through this packet, aren't we? We're just knocking assignments off left and right. And by the way, so when I used to give assignments, they were all book assignments, and I would just rattle off the numbers. So over the years, I've turned every single one into worksheets. And after I turned them into worksheets, I went through, I was like, do we really need 25 problems? Maybe we could cut it down to 17. See what I'm saying? I think that this is as refined as we get. So just to let you know, I'm not trying to give you problems just for the sake of giving you problems. Do you ever have that time where it's like, hey, do problems 1 through 77? You know what I mean? I'm not trying to give you I'm trying to give you problems that will really make a difference for you, okay? So problem number 1, okay, that should be very similar to what we just did, domain and range. No problem should be there. 3 and 4, vertical line test. That should go pretty quick, right? Flip it over. Problem 5, A through F. There you're determining whether or not it's a function by solving for y. We did a couple examples there. And then 6 is where you have the piecewise function. So what's going to take you the most time for this assignment? The piecewise function, that's where you really want to focus. That's where people get stuck before the test. The other stuff generally goes pretty well for people. Okay? You've got a nice 12 minutes. Nice job.